Nickel is element number 28 between cobalt 27 and copper 29. Nickel has been known for a long time as an element or as a mixture with other metals, but it was only isolated as an element in 1751 by Axel Friedrich Cronstedt in Sweden. To begin with, it didn't have really much use, and the big breakthrough for nickel came in the 19th century when it was discovered that if you added nickel to steel, you could make very strong armour, particularly armour plates for ships, so that your ship was stronger than the enemy's and their shells couldn't penetrate. About the same time, a large deposit of nickel or nickel ore was discovered in Sudbury in Ontario in Canada, so that in some ways nickel has become a Canadian element. There are also now large deposits in Russia, but the Canadians have become so proud of nickel. Axel Friedrich Cronstedt, his portrait is on the Premier Medal of the Canadian Institute of Chemistry. It is thought that the nickel deposit in Canada probably came with a meteorite from outer space, because meteorites quite often have a very high nickel content, and presumably in the very distant past a massive meteorite struck what is now Canada and buried itself in the Sudbury region. You don't need a very large diameter meteorite to contain an awful lot of metal. The big breakthrough in the refining of nickel came in 1890 when the British chemist Ludwig Mond, who was a major industrialist, had a problem in his chemical works that some of the nickel valves on his chemical plant were found to corrode, dissolve. And he discovered, or his assistant Kvinke discovered, that this was caused by a reaction between carbon monoxide and nickel. In 1890, they published a key paper about the compound. The compound is called nickel tetracarbonyl. It consists of a central nickel atom surrounded by 4 carbon monoxide groups arranged in a tetrahedron. What made this compound really unusual is that when you think about transition metals, iron, copper, nickel, you think of coloured salts which are solids all the time. Nickel carbonyl was a liquid, it was colourless, and it boiled at 43 degrees centigrade. So it was almost a gas at room temperature. The important thing about nickel carbonyl is that you can distill it easily, and if you heat it up, it decomposes back into nickel and carbon monoxide. So it turned out to be a really good way of purifying nickel ore. And Mond set up a company specifically to get nickel from the ores in Sudbury. So he was reacting the ore with carbon monoxide, which extracted out the nickel and in fact some of the iron, both as these so-called carbonyl compounds. You can then separate them by distillation, heat them up to decompose them, and you get absolutely pure nickel and some iron as well. It was then discovered that nickel was a very good catalyst for reacting organic compounds with hydrogen. And particularly it was discovered that you could hydrogenate vegetable oils, sort of cooking oils that you use, and these oils have carbon-carbon double bonds. If you react these with hydrogen, the melting point of the oils increases, so the material becomes more like butter, and this is how you make margarine, by reacting vegetable oil with hydrogen. The nickel is the catalyst. The hydrogen is absorbed onto the surface of nickel. The organic compounds also absorbed onto the surface, and when the molecules are held there, the hydrogen can transfer from the nickel onto the carbon of the double bond. I was very keen to do a big experiment, demonstration in this video, and I wanted to do it with a material called Rainey nickel. Murray Rainey was an American chemist working on the hydrogenation of fats, trying to make a better catalyst. And the problem with the catalyst is because it is solid and the molecules are absorbing on the surface, the bigger the surface area, within reason, the better the catalyst. So he needed some way of dividing up the nickel so it was in very small particles, so it had a very large surface area. And he hit on the idea of mixing molten aluminium and molten nickel, these melted metals. And they mix when they are liquid, but when they solidify, they separate. So you end up with a lump of aluminium with tiny bits of nickel embedded in the solid, rather like currants or cherries in a cake. You can then put these mixed nickel aluminium pellets into sodium hydroxide. The sodium hydroxide dissolves the aluminium, rather like we've done before with Coke cans, and they leave the nickel quite untouched, but they come out like removing the cherries from the cake, and they have a very large surface area. So now my experiment. I had read that Rainey nickel is pyrophoric. It reacts with oxygen in the air and bursts into flames. So I went to talk to my colleagues in organic chemistry who use Rainey nickel, and you buy it as a slurry, so it's wet, to avoid it bursting into flames. So I got a bottle which looked a bit old, but I was assured was probably okay. And I persuaded Neil to pour it onto a filter paper. And so what I expected was that it would dry out, and then you would be left with these dry, tiny particles of nickel, which would absorb oxygen, start burning, heat up more and more, and burst into spectacular flames. Unfortunately, it didn't. In fact, when Neil eventually set fire to the filter paper, and the nickel didn't seem to burn. Clearly we had a dud batch. I think that the air had got in and slowly dissolved in the water and reacted over a period of months and oxidized the nickel. So probably what we had was some form of nickel oxide, but they're all fairly black in colour, so you can't really tell what you've got. So I rushed off and found another professor who had a much fresher sample, and he came down with his sample, and he told us we had to dry it on a hot plate, and he got quite worried, thought we'd used rather a lot of nickel. We heated it up. We had all the cameras, the GoPro, the thermal camera. Brady's standing there, so excited, and eventually it glowed slightly. And what this demonstrates is that sometimes what chemists tell you about reactions are not always what happens in the lab. However, you've got to imagine that if you're making margarine on a huge scale, tens of thousands of tons, and have got a huge amount of Rainey nickel, then probably you can get quite a serious fire. But we don't have that much Rainey nickel, and we don't want a serious fire. So, well, first of all, let's look at some nickel. Neil has produced some nickel pellets. So these are just labelled as general purpose nickel. They're lumps of nickel. Quite a few chemists like to use nickel spatulas because they are more resistant to strong acids than stainless steel ones. You can have over here, this is quite nice, this is a gauze that is made of very fine nickel wires. I think this one is designed for electrochemistry, so you can get a very high surface area. Nickel is also been used quite often for electroplating in the days when cars had shiny bumpers. I can't remember what Americans call bumpers. Fenders. And these consisted of steel, which were plated with nickel, and on top of the nickel was chromium. So the chromium gave a nice shiny look, but the nickel bonded them together. Nickel has very colourful salts, and our undergraduates in their first year do a very nice experiment where they take nickel chloride that is green and they react this with ammonia so that each nickel atom is surrounded by 6 ammonia atoms. The nickel-ammonia complex is a nice purple colour. They then have to do a separate experiment to measure how much nickel is in the sample to see if they've made it properly. They do this by dissolving up their nice purple compound, adding an organic compound called dimethyl glyoxime, which binds to the nickel and forms an insoluble red precipitate, which they filter off and weigh so they can see how much nickel there is in their compound. So in a single experiment, they have gone from green to purple to red. We're not showing you the experiment because then our students might cheat, so you'll have to come as a student to do it yourself. Then Neil thought about it. He realised that as the water was evaporating and the individual particles of nickel got dry, each of them oxidised, so you never had a whole mass going off at once. So what he decided was to put the wet, rainy nickel in a vacuum desiccator. This is a vessel which you can pump out all the air, and as you're pumping on it, of course the water also evaporates, but the nickel is dried in a vacuum, so there's no oxygen for it to react with. So when he opened the tap, the air containing the oxygen rushed in, and all the nickel reacted at the same time and produced quite a satisfying whoosh.
We've made videos about every element on the periodic table. If you'd like to watch them in order, I'll put a link on the screen and in the video description. There's a playlist of them all, 1 to 118. Might take you a little while. We're constantly updating these videos with new ones, like the nickel video you just watched. And in fact, we've filmed so much about nickel, there's some leftovers. If you'd like to watch them, I'm also linking to the extra footage. You can go and check out even more details the professor had to share.